Alright, let's continue our learning about trigonometry and talk about the coordinate definitions of trig functions, which we probably already learned about in the previous section, but we're going to revisit it. Okay, quick reminder, reference angles are the angles formed between the terminal side and the x-axis. Alright, so I need to emphasize that, like green, good, okay, green reference angle, green reference angle, green reference angle, green reference angle. Okay, red, bad. Not the reference angle. Definitely not the reference angle. Totally not the reference angle. Not the reference angle. Alright? Never use the angle formed by the terminal side and the x-axis for the reference angle. The y-axis. Never do the y-axis. It's always, so green, good. It's always going to be the terminal side and the x-axis is the reference angle. Alright, and we use these symbols to indicate it. Okay, so when we use the reference angle, that allows us to redefine SOHCAHTOA as sine is y over r, cosine is x over r, tangent is y over x, where x and y is a point on your terminal side, and r is the distance that that point is from the origin. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. Right, and these allow us to take the trig function of any angle outside of the range between 0 and 90. Right, and that was talked about a lot in the previous video. So if this doesn't really make a lot of sense, please look at the 1.6 video. Okay, ASTC, all students take calculus. Adam Scavola teaches calculus. Adam Scavola tastes cannolis, however you want to use. That is a way to remember what quadrants each trig function sign is going to be. So A means quadrant 1, all the trig functions are positive. Quadrant 2, only sine and cosecant, alright, and you can read that chart right there. This was also explained in the previous video, just wanted to remind you of it. Okay, so you could guess what angle theta terminates in if you have certain information. So guess the quadrant of theta, given that the cosine of theta is positive and the tangent of theta is negative, alright, so that's kind of like, I should have fixed that, but I'm not going to in the video. I'm already 3 minutes in, so we're stuck here. So if the cosine of theta is positive, okay, the only time the cosine is positive is in quadrant 1 and quadrant 4. So if the cosine of theta is positive, we know that theta is not going to terminate in quadrants 2 or 3. Alright, now tangent is negative in quadrant 2 and quadrant 4. It's positive in quadrant 1 and quadrant 3. So we want to know where tangent's negative and cosine's positive, so we're going to eliminate these two quadrants. So we're left with quadrant 4. So quadrant 4 is where the cosine of theta is positive and the tangent of theta is negative. Alright, now where does secant and cosecant have the same sign? So let's look at it. Secant is all, so all trig functions are positive in quadrant 1. Only sine and therefore cosecant is positive in quadrant 2. Alright, secant would be negative in quadrant 3, but positive in quadrant 4. So those are the signs of cosecant. Now for cosecant, all trig functions are positive in quadrant 1. Alright, cosecant is going to be positive in quadrant 2 because that's where sine's positive. Cosecant will be negative in quadrant 3 and negative in quadrant 4 because sine is negative in those quadrants. So if we look, we see that, okay, both these functions have the same sign in quadrant 1 and in quadrant 3. So theta would have to terminate in one of these two quadrants.